Good morning. Hey, it looks like I did have an error on the second part of the equation on the lesson on 1.6 on the absolute values. So hopefully this will fix it. I'm sorry about that. I grabbed this same video twice. When we jump into absolute values, I want to just go ahead and we look at the definition. So a definition of an absolute value is when it's the distance the number is from 0. So when I look at, say, a number and I say I have the absolute value of 5, it's going to equal 5. If I have the value of negative 5, it is also 5. And way back, I used to say I always want you to have an absolute value attitude. So if you had a positive attitude coming in, make sure you have a positive attitude when you leave. If you came in with a negative attitude, I hope it'll be positive. But when you look at it in terms of when we're solving values for numbers, so let's just change it and I say x is going to equal, say, 9. Well, easily the value of x could equal 9. So if I take the absolute value of a negative 9, I get 9. So that means I have or negative 9 is my answer. So when I'm starting to solve equations, you need to think in terms of that I've got two different values that I could have. And so what I like to do is think about in terms when I solve absolute values, my first step is always to get the absolute value by itself, okay, and solve it, get it isolated. And then I look to make sure that I have an equation, because if it's equal to some negative number, then I'm going to quit, because there's no way I can take an absolute value and get a negative number back. And in this case, because it's a 9, that means I have a solution. In fact, I'm going to have two different solutions. So the first one I think about is going to be when it's positive, when I have the value in front, if it is that the inside, the 2x minus 3 is just going to be a norm. It's the positive case. And so if I set 2x minus 3 is equal to 9, then I can solve for x. But I'm also going to know that inside here, that the 2x, the negative side, that negative times the 2x minus 3 is also equal to 9 as well. And I don't usually do it this way, because I just go ahead and just change my answer, because I know that if I can multiply both sides of the equation times a negative, that means 2x minus 3, which is what's inside my absolute value, is going to equal a negative 9. So that's where I have a positive case and I have a negative case, and that's how I get that. And I just solve like I do before. So I'm going to move my 3 to the other side, so I'm going to go plus 3. So I have 2x is going to equal 12, and then x is going to equal 6. And that makes sense if I substitute that back in. I'm going to 2 times 6 minus 3 and take the opposite value of it. That's going to be 12 minus 3, which is 9. And that's going to equal then the absolute value of 9, which is going to equal 9. But then on the negative side, if I go ahead and solve this when it's negative over here, if I add 3 to both sides, then I have negative 9 plus 3. That's going to be a negative 6. So I have 2x is equal to a negative 6. Then x is going to equal then a negative 3. And so if I put that back into my equation, I have the absolute value of 2 times a negative 3 minus 3. And 2 times a negative 3 is negative 6, minus 3 is going to be the absolute value of a negative 9, which is also equal to 9. And so my two solutions would be then negative 3 and also when x is equal to 6. Now look at the second equation. When I have this scenario, what I want to do first is isolate my absolute value. And keep in mind, if I have a number out in front, I would still want to divide it, and I want to get just the absolute value all by itself. But I'm going to start off by moving my 8 to the other side, so I'm going to subtract 8. So I have the absolute value of x plus 3 is equal to a negative 2. Now, I need to stop there and think, if I'm going to take the absolute value, whatever value I have in here, am I ever going to have it equal a negative number? And in this case, I would just stop. I cannot solve this, so this is a no solution. So keep in mind, anytime your absolute value after you isolate it is equal to a negative number, your answer is just going to be a no solution. I'm going to add another one because it's similar to one we have on our test that we have coming up. So if I have 2 times the absolute value, let's say of x plus 1, oops, that's the absolute value, excuse me. I'm going to go minus 3 is equal to 4. So when I solve this, I'm going to move my 3 to the other sides. you know what I ought to do? I'm going to make this, I'm going to change this real quick to 5, that way I have an even number. So since I'm making problems up, I can definitely have the ability to do that. So I have the absolute value of 2 times x plus 1, and then I'm going to move my 3 over the other side, so it's going to equal now 8. Now I've got to get rid of my 2 as well, so I'm going to divide both sides by 2. So I have the absolute value of x plus 1 is equal then to 4. And this is where I just, like I had before, I would have my 2 cases. I would have my positive case and my negative case. And so I'd have then x plus 1 is equal to 4. I like to do x plus 1 is equal to negative 4, and then I would just solve. So I'm going to subtract 1 from both sides, and then so x is going to equal 3, and then x is going to equal then a negative 5. When I have a case like this C that I have where it looks like I've got quite a mess, but I've got a case where I have absolute values on both sides. And so when I think about my positive case, it's still going to be just writing the equation without the absolute values. So I have 8x minus 17 is equal to 4x plus 16. Now what I find is if I solve this equation, I'm going to move my 4 to the other side, so I'm going to have 4x, I'm going to add the 17 to both sides is equal to 32, and then x is going to equal 8. So keep that in mind. Now if I think about in terms of what happens if inside here we're both negative. So if I have this as a negative times 8x minus 17 is equal to a negative times 4x plus 16, and I distribute, I could actually multiply both sides by negative right now, and I'd get the same thing I had before. But let's say I didn't see that, and I said a negative 8x plus 17 is equal to a negative 4x minus 17 or 16. And I'm going to go ahead and move my 8 to the side to keep my positive value. So I'm going to add 8, so I'm going to end up with 4x. I'm going to add the 16 over, and I'm going to end up with 32. And notice, I'm going to get the same answer that I had before. But where you don't have that is when one of these would be negative. Okay, so I'm going to show you on the first one. I'm going to just make the first one negative. So if I have a negative times 8x minus 17, but then the next one happened to be positive, so it's going to be 4x plus 16. I'm going to get a solution, so it's going to be a negative 8x plus 17 is equal to 4x plus 16. And then I'm going to solve. I'm going to move my 8 to the other side, so I'm adding 8, so that's going to make it 12x, and I'm going to subtract my 16, and so I'm going to minus 16 would give me 1. And so x is going to equal then 1/12. And if I substitute that back in, I'm going to find out that I'm going to get the same answer. So keep that in mind, I get 1/12. That's when we made the first one negative, but the second one positive. Notice if I make the first one positive, so I have 8x minus 17 is equal to now a negative times 4x plus 16. And I distribute my negative, so I'm going to have negative 4x minus 16. And then I'm going to move, I have 8x minus 17. I'm going to move my 4 to the other side, so then it's going to give me 12x, and I'm going to add the 17 over. So negative 16 plus 17 is going to give me 1, and x to 1/12. Notice the same as I had before. So when you're doing ones where you have absolute values on both sides, really what you need to do for your positive case is just make both of them positive, and then for your negative case, you want to make one of them negative and then solve, because you're going to get the same answer regardless of which way you go. This last part is just simply putting your formula in. So in other words, a basketball player's hang time when shooting is in the formula T equals the square root of D over 2. And in this case, I'm just going to go, when a particular player dunked the basketball, the hang time was approximately 1.04 seconds. So what I'm going to do is I'm going to substitute that back in for my T, and I'm going to have 1.04 is equal to the square root of D over 2. Now, we still want to isolate the radical like we've done before. So in other words, I'm going to multiply both sides of the equation by 2. This one's fairly easy. 2.8 is equal to the square root of D. And then what I'm going to do is I want to get rid of my radical. I'm going to square both sides. And then this is where I would grab my calculator. So 2.08 squared is going to equal then a distance then of 4.3264. And keep in mind, we do want to make sure we put our units, and in this case, oh, there it is, feet. So I'm going to have then feet. All right, that should take care of this lesson. Hey, I am going to go ahead and start putting some reviews for your test that's coming up next week. And so they'll have some videos where you can look at the to see how to do the problems through the review. See you.